Alright, ladies and gentlemen, welcome back to the wonderful world of pre-calc. Okay, we're going to be talking about identities here. Section 5.2 is all about them. We've kind of done these before, so this hopefully won't take too long here, but we're going to be verifying trigonometric identities. Okay, now the rules. Number one, you may only modify one side of the equation. And number two, you may only modify one side of the equation. Alright, so basically again, the second you do something to both sides, or anything of that nature, you're automatically breaking the rules and you're wrong. So please don't do that. Alright, number three, you're finished and one side is identical to the other side. Again, don't leave it as 1 plus 1 equals 2. You have to simplify it down to 2 equals 2. And then, of course, the final answer is all the work, not just the last step, because it is a proof of sorts. Okay, let's give one or two a shot. Alrighty, so for verifying identities, basically a good rule of thumb is to modify whichever side looks more complicated. Before today, we've always been looking at, well, okay, do the left side, make it look like the right, or so there was some kind of a direction given one way or the other. This one is going to be a little more open, and basically there you go, modify whichever one looks worse. Because those simplification rules that we did before, that's basically what we should be shooting for. So simplify something that looks messy, hopefully it'll come out looking like something that's not as messy. Alright, so anyway, first thing first here, I've got my right side looks a little messier because it's a fraction. That's the sole reason I would do this. Okay, now sometimes it might not be super clear what to do. Again, turning things into sines and cosines is always a good move, and well, we already have it, so let's try something else. We're going to do something that looks a lot like a rationalizing the denominator. Okay, I've got kind of a conjugate sort of situation here. If I have 1 minus cosine, I can use 1 plus cosine x. And again, that's really, really nice because of our Pythagorean identities. Anytime I have 1 and a cosine, if I can multiply by its conjugate, I'll end up with a 1 and then one of my trig functions squared. And, I'll also be able to replace one of those with something else if I need to. So maybe that'll work out well for us here. Okay, so by doing this, okay, my numerator becomes sine of x plus, I'm distributing, sine of x cosine of x. And then my denominator becomes, well, 1 minus cosine squared x. Again, just doing a difference of square sort of thing. Okay, my numerator I'm not going to mess with anything quite yet, just mostly for helping show the steps here. So sine x plus sine x cosine x. And then that's all over, well, 1 minus cosine squared, using my Pythagorean identities, which you need to have down very, very well, becomes sine squared. Okay, and here we go. I'm going to now break this. If I have a single denominator and multiple terms in my numerator, what I can always do is break that into multiple fractions. So I'm going to call this sine of x over sine squared x, and then plus sine x cosine x over sine squared x. Alrighty, hopefully I can fit this in. Alright, now the sine over sine squared simplifies to 1 over sine. And then likewise the sine can reduce here, and leaving me with cosine over sine. And finally, 1 over sine is the same thing as cosecant. And then of course cosine over sine is cotangent, which lo and behold is what I started with. Alright, if you want to not copy that left side over and over again, especially because sometimes one of the sides is going to be a little bit annoying and recopying it a lot doesn't make a whole lot of sense. What I like to do is just my own little shorthand, is basically just draw an arrow straight down and then recopy it as the last step to make it look all nice and pretty. But there you go. And again, the entirety of this body of work is my final answer. So there you go. That's what one of those things will look like. Okay, I'd like to do another one now just to kind of demonstrate a way of cheating, as it says there in the upper right hand corner. Sometimes you can do a little bit of cheating, and well, you have to fix it, and let me demonstrate that. It may not be totally necessary on this problem, but honestly it's one of those opinion things that it's necessary for one person and not for another. So here we go, and let me stop babbling. Alright, so I've got secant minus cosine and then sine times tangent. Now immediately it's not real obvious which one's worse than the other, so maybe a tough call. But I think I'm going to start by messing with the secant x minus cosine x. Alright, so I'm going to turn this into 1 over cosine x, and then cosine x over 1, and then again I'll just leave that alone and do my arrow in just a little bit. Alright, so I've got this. Well, again, I've got two fractions, so common denominator sounds like a good plan. So cosine is my common denominator, so I don't need to mess with my first fraction, so 1 over cosine x stays true. And then if I hit this guy top and bottom with cosine, I'll get cosine squared x over cosine. Okay, then hopefully this numerator sort of thing is looking a little familiar. I've got 1 minus cosine squared x all over cosine x. And get the equal signs going here. Alright, now again, I think we've seen this enough times that we know that that's going to be sine squared x over cosine x. Okay, and at this point you might be like, oh, I'm kind of stuck. Alright, you may see what to do, you may not, but here's where the cheating comes into play, if you will. Okay, so going back to the other side, if we get to a place that I look like I'm pretty simplified, but I'm just kind of stuck, I'll go back up to the original, and if I can turn the original into this, then at least gives me a path to go by. So kind of off to the side, because I don't want to mess up my work. Alright, sine, I can think of that as sine over 1 times, well, tangent is sine over cosine. Okay, well, now basically what this lets me do is this is an intermediate step I can put in underneath here, because hopefully you can look at the sine squared over cosine and kind of see that reflected here. So basically now tearing this thing apart a little bit into something like that gives me a little bit of a hint of what step that I could take from here. And this isn't obviously something you can get from this, maybe do another step. And then again, maybe it takes 2 steps of cheating, if you will. But basically the fixing, I mean, is instead of turning this into this, it just gives me a pathway of turning this left side here into this. So again, I'm breaking this up into a product. So this becomes sine x over 1 times, and as a dot right there, sine over cosine, which then immediately becomes sine all by itself, and then sine over cosine, of course, is tangent. And then again, by cheating and then fixing it, you can see how the left side will actually turn on the right-hand side. So again, just recopying this, and everybody's happy. Well, at least I am. Alrighty, so what it says here, okay, instead of me doing another 20 examples or something like that, basically this is one of the things you have to play to get better, and you're going to make mistakes. One of those things is you have to know all those trig identities backwards and forwards and upside down best you can. Okay, of course I gave some tricks about that, where, you know, as long as you know the Pythagorean one with sine squared plus cosine squared equals 1, you can manipulate it around to get the other two, but you need to be able to do that relatively quickly. If it takes you 5 minutes to figure that out, then, well, you need to think about memorizing it all. And big thing is you're going to have to figure out how to fix these yourself. You're going to make mistakes. Sometimes you're going to take a few steps and you're going to be like, oh my gosh, I'm lost. I have no idea what to do. But my advice basically is, sometimes 1 or 2 steps into it, it won't really look like it's doing anything. Maybe you need to go 3 or 4 steps into it before things start kind of gelling into something that looks reasonable. Or, of course, you can do that little cheating thing I showed in the last problem. But you got to play. Not much else I can do with it. Alright, anyway, other than that, kind of breaking this into 2 days, but honestly, you know, within 2 days we need to do basically 1 through 49. Skip 25, there's something in there that I'm not too worried about. But other than that, there it is. Of course, again, as always, ask for help if you need it, and I will see you in class.